Hello guys, my name is Akash Kamlesh and I am one of the developers of Project Baraat. Project Baraat is a project that was selected in the Open Source AI Hackathon in the Fifth Elephant Winter Edition Hackathon by Hasgeek. So I'm here today to give you a demonstration and a detailed overview of our project to talk to you about what we're doing and why we are doing what we're doing and to also talk about the specifics of what we've achieved and tried so far. So, the main problem statement that inspired us is that we see a lot of advancement and progress towards building parameter efficient language models, reducing the additional trainable parameters, making smaller, more compact language models, etc. So the focus right now is on benchmarks and improving numbers. That's where the Gen AI race is heading towards in the NLP space. So we saw this and we realized that LLMs are not more accessible in the sense that you're not extending the support for an LLM to the native speakers of a country, for example. All the focus right now is on English, and those are what benchmarks are usually evaluated against. So, the main takeaway is that we have identified Indian languages as a source, and that is what we have created this project for. So, Project Bharat is an open source initiative to leverage the power of LLMs on Indic NLP tasks. So we have built pre-trained models on Hindi and Kannada languages. We also plan to extend the same with further Indic languages in the near future. This has only been possible due to a lot of heavy lifting and a lot of work from AI for Bharat. So we extend a huge support and a shout out to them. So Project Bharat is more than just an LLM. It is a hub of LLMs pre-training data sets that we have curated and cleaned from multiple sources, such as Wikipedia or from text from corpuses online, IndicCorp from AI for Bharat are a few to name, etc. So we have cleaned, curated, and combined data, and we have created data sets for different tasks. So this is our project on Hugging Face, and we have all our fine-tuned models up on Hugging Face for Hindi and Kannada. So you can see we have a question answering fine-tuned model, an instruct tuned model for Kannada, etc. And we also have released our datasets, which we have used for fine-tuning and for pre-training. So we have our Hindi pre-training data and other datasets as well, just to name a few. So yep, coming back to our project, it is an open source initiative again, so we will encourage open source collaboration and support. We plan on making a multilingual and a cross-lingual LLM, essentially in a mixture of expert setup. So we have multilingual LLM support already. That is our fine-tuned model. So you can talk to them in English, the language, or in the Romanized form of that language, etc. Cross-lingual is a feature that we've introduced through a mixture of expert setup, which we will talk about. How we approach this problem statement is that we first created a pre-trained model for a particular language, and we saved that model onto Hugging Face, and we then loaded various instances of the pre-trained model as our new base model, and we fine-tuned them for specific tasks. So we identified 4 tasks. The first task being translation between a source language and English. We have considered combinations of English to the target language, the language to English, the Romanized form, etc., and vice versa. Then we also have mathematical and logical reasoning as well. We have question answering models and the instruct fine tune model. So we have a total of 4 fine-tuned LLMs, and these LLMs are fine-tuned of a pre-trained model that was created one step earlier. Coming to our roadmap, we curate datasets via an extension of existing datasets from different sources, as mentioned earlier, with synthetically generated data as well about fruits, vegetables, and colors. The reason we did this is because we need to instill the knowledge to the LLM for that particular language. That, for example, banana is not just banana in Hindi, right? So, try incorporating that knowledge corpora is very important in pre-training. So that is why we did this step. We created pipelines to automate the cleaning process and batching the sentences to create longer sequences for pre-training. So we ensure that there's a uniform chunk size of around 512 tokens or 256 tokens minimum. We have the second step was after creating datasets was to prepare and set up tokenizers. Existing tokenizers were built keeping English as a target language in mind. We've created and extended the vocabulary of the existing Llama 2 tokenizer. Our base model of choice is Llama 2, and we've worked with a 7 billion parameter variant. So all our experiments were run against 7 billion parameter models. So we created two sentence piece tokenizers following the byte pair encoding architecture which Llama 2 uses, and extended the Llama 2 tokenizer with an extra 16,000 tokens for a particular language. So we have a tokenizer for Hindi and a modified tokenizer for Kannada as well. So this approach prioritizes efficiency during tokenization, particularly crucial for faster processing during inference because it will generate lesser tokens and more grammatically correct tokens. Next, once we have a tokenizer and dataset set up, we can start with our first phase, that is pre-training. So pre-training, how do we do this? We leverage a very popular open source AI framework called Unsloth. Unsloth is a very emerging tool that has been shown to display wonderful speed up in terms of fine tuning and during inference. So we've used Unsloth with Llama 2 as our base model. So along with the particular languages tokenizer with the pre-training dataset. So we pre-train the model with using LoRa. So we create LoRa adapters, and we've chosen a rank size of 256 for pre-training, and we train the same for around 150,000 steps odd. And we after training we merge the pre-trained model and save it as a 16-bit VLLM and push it to HuggingFace. So this model is now our new base model, which we will base all fine-tuning off. Coming to step 4, where we fine-tune the model, we utilize pre-trained models as the foundation model, which is what I just said earlier, and then we refine multiple instances tailored to specific tasks. So we create 4 different instances for 4 different tasks and fine-tune them with a lower rank size of 32 and approximately 100,000 steps, which turns out to be 0.2 of an epoch. Once we have all our fine-tuned experts from different languages set up, we implement our mixture of experts. So we create our mixture of experts through a gradient-free merging method in a mixture style LLM. We utilize a framework called MergeKit for this operation. MergeKit provides very easy merging methods for different LLMs of the same architecture or of different architectures. So we use our fine-tuned models of different languages, and we have created 2 experts, one for Hindi and one for Kannada. Next, we implement our language routing function. So why are we doing this? Because we said we want to enable cross-lingual communication, right? This is a language routing mixture of experts problem here. And once the tokens are routed appropriately, you get your output in the target language. And once this is done, we have also created a Python package. Why do we do this? Because we decided that this is an open source hackathon, and it's not just about creating, obviously it's about creating something new, but at the end of the day we are also fostering community support. So all our work is documented through the Python package, and we've also added a lot of pipelines for tokenization, data ingestion, data cleaning, etc., which is what we followed. And now we have a video showcasing our journey and highlighting a few use cases. So let's go down. You can see we have details about pre-trained models. You can find the same on our GitHub repository. So the key features again of our project is not just a model. We provide very rich tokenizers for Indian languages. We have fine-tuned language models readily usable for inference or for further training. We foster open source collaboration, and we have very high quality data sets which have been cleaned, pre-processed, and meticulously looked at for quality. So let's go over our architecture. This is the left hand side in orange is the pre-processing step where we have your input data, and we first filter the data to contain only Hindi or Kannada and English characters, and then we remove special characters that are there in the data, but we preserve some characters such as the line and the vertical line and the colon, because sometimes the vertical line is used as a full stop in Hindi. Then we perform Virama filtering and correction on the data, and then we bashed inputs to create longer sentences, just so that there's a uniformity in the length of the sentences. Yes, so this is our pre-processed text, and we push them to different data sets on our Hugging Face hub. Next step, which is where the model training starts, we load in our pre-processed text, and we identify and we start fine-tuning our models. After we fine-tune our models, any input query is first passed into our language router, and the source and target languages are identified through a language router. If so, currently the way we're using cross-lingual capability is, since we're using gradient-free merged models, we have not trained them together. That is a very important point to make here. So, language 1 model does not know about language 2 on its own. So, to facilitate cross-lingual capability here, we have an English intermediate model that's running along on the side. So, if you wanted to do cross-lingual inference, for example, from language A to language B, we would first pass our sentence or our query to the language router. The language router identifies the source as language A and the target as language B. It then translates the sentence from language A to English, and then sends that translated English sentence to the language expert B, because language expert B will be able to understand the query in English and give you the output in target language B. So I hope that's very clear. And yeah, after that, at the end of it, you get your response. So this is our architecture for the language routed cross-lingual mixture of experts. Obviously, this is not the best way, but since we're using gradient-free merging methods, this is one of the ways we can approach this. Later on in the near future, we plan on experimenting with switch transformers on the same. So yes, again, our foundational model is Llama 2. Coming to our future scope, we plan to extend support for images and audio. That is as the input data. We also plan to release a pipeline for automated dataset cleaning. Then we also plan to have enhanced reasoning ability and fine tuning. So as of now, we're using MetaMath, and we're currently using MetaMath. But we wanted to see that we don't want to stop at just one data set, but we wanted to possibly use multiple data sets just to help improve the logical reasoning capability of our models. So yeah, this is it for our GitHub repository or our code walkthrough. We now have a few demos for you. As I mentioned, we have created a Python package documenting all our work, and just to create a very simple pipeline for utilizing our project. So it's a very detailed description about how to use the package and how to get started with the package. So this is just the same information about what we saw earlier. We have a very detailed documentation of the installation instructions, so all the dependencies, etc., how to install the package and how to use the package as well. And as we said, the project is continuously undergoing updates, and we're releasing a very critical update very soon. Let's go proceed to the code demo. We have our Jupyter notebook that can be found on our GitHub repository as well. So this is just a very small notebook that shows you how you can use our project. So to use our project, again, coming back from the PyPy website, the same code. We first have to set up the dependencies, and as you can see, we just have to install unsloth, our package, and seamless for now. So the reason why we're using Seamless is because we plan to introduce voice support, and we plan to introduce voice support as an input and as an audio output. So currently it's still being implemented, but as of now there's two functions that have been defined in the package that utilize Seamless. So for now, Seamless is a requirement to be installed. Yeah, so we can see that we use our package to load a language model. As of now, we have a few language models that have been released and are available to be used. So it's very simple. All you have to do is just say model comma tokenizer is language router dot load individual models, and these you can choose one model from the list of these models. This list is currently being updated, and once we finish the release of the Python package, we'll update the same. Coming back, this is how we load our model. It's very simple, straightforward, just using one utility function. And this uses unsloth in the background and loads our model from HuggingFace along with a tokenizer. Next, we have our prompting. So yeah, this is a very important step because we have fine-tuned our LLMs using a prompt template, and this is again the standard alpaca prompt with the instruction response, slightly modified, but it's very important to know to use the prompt templates appropriately for the different models, because otherwise they might generate wrong outputs. Yeah, so this is an example. So we the same thing. All we have to do is just use utilities dot get prompt template, and these are the prompt templates available. One prompt template for each model. So just load the appropriate prompt template for the model that you loaded. So in this case, we loaded the instruct model from Hindi, and we get the appropriate prompt template, and you can see this is what it looks like. Then we use a text streamer from transformers just to keep it interactive, the text generation interactive, and you can start running inference against the model using model.generate. So this is pretty much it, and that's how simple it is to use our project, our tool. Again, the main goal of this project is hidden by the fact that we have all our models ready here, our data sets, our tokenizers, pipelines for data cleaning, etc. Yeah, and the main takeaway is the mixture of experts model, of course, for cross-lingual capability, and we again plan on implementing training through switch transformers. The main reason we stopped was because we hit a lot of dead ends while doing that, mainly due to having different tokenizers, right, for each language. So we faced a few issues there. But in the near future, we will keep trying and we'll keep inventing. Till then, thank you. And thank you so much for listening to this demo. I hope you found it interactive and interesting. And please do start the repository on GitHub. It would help us a lot. Thank you so much.